T.S. Eliot once said, "Do I dare disturb the universe?" My reply to that is, you have no choice. To begin to understand entropy, we can say that it basically measures the uselessness of a certain amount of energy. Many may even refer to it as simply as disorder and chaos that tends to always be increasing within our universe. So with that statement, when I talk about entropy, I mean our universe is entropy. When we discuss entropy, we are also taking note of the second famous law of thermodynamics. While the first law states about how energy and matter is neither created or destroyed, the second states that within an isolated system, entropy either remains constant or increases. Our universe is an isolated system. An isolated system may be quite confusing to hear though, so to simplify it, it is basically something that has no surroundings, and as a result, energy and matter cannot be exchanged with surroundings that don't exist. Space is space, it's infinite, and it has no surroundings. So like I said before, we can see that our universe is an isolated system. If I haven't been helping you understand such, maybe physicist Ludwig Boltzmann could. He simply stated that entropy tends to increase in our universe because there are more ways to be high entropy than to be low entropy. If it's hard to wrap your head around the concept of entropy, maybe some examples would be helpful. It's a Friday night and you can't find any clothes to wear. As a result, you try on different outfits and leave the clothes scattered upon the floor. So, when the clothes were in the drawers, the entropy was lower than when they became scattered upon the floor. There has been an increase in disorder. We started with an easy example, so let's move up a step. The Big Bang Theory believes that at the beginning of the universe, the entropy was low. There wasn't much disorder going on within our universe, and yet the explosion was to believe have happened, and here we are with an everlasting emptiness. Low entropy to high entropy, not so chaotic to very chaotic. Are you still with me? If so, I'm deciding to take it up to a whole different level. We learned that heat flows from hot objects to cold ones. This happens until both reach a state of equilibrium. But with Earth absorbing the sun's energy, why is it that the Earth and the sun don't have the ability to fully reach equilibrium together? Well, physicist Sean Carroll explained this simply stating that because space is colder. As Earth absorbs the sun's heat, Earth is also radiating the heat into space, a hot object to a warm object to a cold object. But due to space's infinite distance, it would be impossible to reach a state of equilibrium. As that happens, if you have been paying good attention, you may note that entropy is increasing. You are correct. The Earth takes a low entropy radiation, makes use of it, and then radiates it into high entropy radiation. So hopefully by now it has been possible to grasp the concept of entropy. But now the question is if it will increase forever in our universe or reach a constant state. We are to believe that it will forever increase, but physicist Sean Carroll continued to discuss that given a box of gas in a high entropy state, it still has the possibility of meeting a pause. They noted that the time it would take for that to happen would be older than the universe's age, so it's not exactly something to worry about, but it still may happen. Overall, we have yet to fully understand if the universe will continue to grow forever. Besides the universe's effect due to entropy, how does it play an effect within our own lives? Well, have you ever wondered why you remember the past and not the future? That's because of entropy. Entropy helps form the arrow of time from past to present and leads us to the idea that there'll also be the future. The reason we grow old is due to entropy, low to high. In other words, an increase in entropy is an increase of time. So is it safe to say that if entropy didn't increase, our arrow of time would be different? Yes. Sean Carroll gave the example of the White Queen from Alice in Wonderland. The scene began with the Queen shouting. "What is the matter?" Alice said. "Have you pricked your finger?" "I haven't pricked it yet," the Queen said, "but I soon shall." "When do you expect to do it?" Alice asked. "When I fasten my shawl again," the poor Queen groaned out. "The brooch will come undone directly." As she said the words, the brooch flew open and the Queen clutched wildly at it. "Take care," cried Alice. "You're holding it all crooked." And she caught the brooch, but it was too late. The pin had slipped and the Queen had pricked her finger. So with that example, it may be easier to understand that within Wonderland, it is not necessary that entropy increases like our universe, so the Queen was able to tell the future before it happened. As a result, we can easily say that due to an increase of entropy, we have free will. The same free will that has sat me on this step to contemplate the effect of entropy within our worlds. That's within our solar system. That's within our galaxy. That's within our universe. It's easy to say how tiny I am within it all, but by having the ability to learn more about something like entropy, I gain the ability to understand this enormous idea just a little better. And with that said, no, I don't feel that small.